In this video, you'll learn how nullable types are implemented at the bytecode level. Also, we'll look at nullability and generics, and you'll learn the difference between a list of nullable values and a nullable list. Under the hood, nullable types are implemented using annotations. So we just use nullable and not null annotations, which gives us no performance overhead of using nullable types. There is another solution to the same nullability problem, which is called optional or option types, and there are just special classes that store a value or absence of the value, and you can check whether there is the value available or not, and that basically solves the same problem, kind of, as nullable types, because these optionals allow you to say explicitly whether this variable can have no value option, or like similar to null or not. Nullable types provide the same functionality. However, of course, these solutions solve the same problem, but they are very different in terms of the performance, because option types is a wrapper which wrap the actual object, and you always have to access it. So for each object, for each value, an extra object is created. While nullable types don't create any wrapper; it's just implemented using annotations. To make sure you understand it, answer this question: how many objects are created to store a value of a nullable string? And their answer options are either 1 or 2. So only one object is created to store a string value. So again, there is no additional wrapper as with optionals. Nullable types, when you use nullable types, under the hood, they're compiled to just they add additional annotations at a compilation time, which are checked at a compilation time. But at runtime, it is the same string as regular Java string. So both types, string and nullable string, correspond to string type in Java, but with annotated type with annotations. So at runtime, it's one string. There is no wrapper. Everything is implemented via annotations. That's the end of the first story, and there is another story, not about annotations, but about nullability and generics. And here, in this picture, you can see the difference between a list of nullable elements and a nullable list. So when you use list of ints, you can put question mark either after int or after list itself, or in both places. And the first one means that every element might be either null or not null, and the second one means that the whole list might be either non-null or null. And to better understand everything, mark here the lines that need a question mark to make the code compile. Of course, you can add question mark to each line, like make each access safe access and make int nullable int, but that's not the question. The question is which are the minimum amount of question marks to make this compile, so that add only question marks that are really needed. So let's do it one by one. The first list is the list of nullable values, and here we can dereference it without problem because it's a non-null reference. But when we try to assign the first element into variable, we see the error because inferred type is nullable int, but int was expected. Because we see that the content of the list is this nullable int, and that means that we need to add the question mark to the type of element. That's all for the first list. For the second case, it's a little bit more complicated, and here we have a nullable list, and that means that both access won't compile. We need here safe access, so we need to add couple of question marks here. And here's the tricky place, because you have added here the question mark that makes line 6 uncompiled, because here you have the type mismatch, and for type is nullable int, but int regular int was expected. That makes us to add another question mark to line 5. So the answer is lines 2, 3, 5, and 6. In this video, you've learned that nullable types are implemented using annotations. That brings no performance overhead. Also, now you can confidently use question mark to mark either the list element type as nullable or the list itself. Next, we are going to look at the new operator that makes type casts safe in Kotlin.